With a keen eye, you might be able to see that engine nozzle gimbaling down there at the bottom.
Yep, I see it.
Hard to tell from this far, but beautiful views. All right, we're also keeping an eye on the pressures and temperatures in those propellant tanks. Both need to stay in that green zone, that go zone. All right, we're at T-minus 30 seconds and counting.
All right, Alice, well, here we go. It's time to hand it off to mission control now and launch this rocket.
T-minus 16, guidance internal.
MMT, we're going to go on this morning. We're isolated.
T-minus 10, 9, 8, 7, 6, 5, 4. Commanded to start. 2, 1, 0. And liftoff.
Shepard has cleared the tower, heading to space. Now you'll note the altitude and the speed graphics that are appearing on the lower side of your screen there. They are tracking both vehicles together, specifically the crew capsule. Once we hit that moment of separation, it'll continue to track the crew capsule's speed. Now the atmosphere, of course, is getting thinner and thinner as we approach space.
10,000 feet.
BE-3 at the moment is approaching 100% power level. And next up, you're going to see max Q. This is the moment where the aerodynamic stress of the vehicle is on its maximum. As we do that, the BE-3 engine is going to throttle back just a little bit as we pierce through the atmosphere. And we've passed max Q. So at this point, BE-3 is back to 100% of its power. It's accelerating faster and faster as it reaches up through the thinner, higher upper atmosphere. And the payloads are experiencing about 3 Gs on the flight at this moment in time. About a minute, 45 seconds of boost so far. Now the velocity meter, as you can see, is not correct. We're going much faster than 25 miles per hour, so ignore that. Trust your eyes as you watch that vehicle fly. These onboard views are very helpful to see, as you can see the Earth descending away from the camera there. All right, we've hit MECO. Main engine cut off. Shortly here, we'll see separation. All right, the 0G indicator there means that we have reached separation of the two vehicles, and now the crew capsule and the booster are now coasting to their apogees simultaneously, and you can see that clean separation now between those two vehicles. Very, very pretty. That's a good, clean view.
The capsule at this point will begin its spin up for the payloads inside to experience not 0G today, but lunar G.
It's a little hard to see from this camera view, but we can't wait to see those results. Now the booster has begun its descent. You can see that booster is making, there's a lot of separation there between the crew capsule, the top picture, and the booster down below. The data that you're seeing now needs to be refreshed on the screen, so apologies for that, but the booster is going to land about 2 miles north of the launch pad down in West Texas, right back at the launch site.
And I'm hearing that the crew capsule is at full lunar G roll, so it has reached full lunar G. Those payloads experiencing that, conducting their experiments, doing all the science that they've waited months and years for in some cases.
That's right. Yes, we've been looking forward to this flight for a very long time. Now, you notice the last time we tried to do this launch, there was a cloud cover. Today, there's no clouds, so our long-range cameras are able to clearly see the view all the way up to space and track both vehicles together. And you can see that booster is descending. Now, it's at this point in time, it's re-encountering the atmosphere, and it'll begin using its steering fins to be able to guide it autonomously all the way back to the launch pad, or not the launch pad, but the landing pad, which is very, very much nearby, about 2 miles north of the launch pad.
At this point, the capsule has also reached its apogee, and it is still spinning, but it will begin to slow down as it and stop spinning as we re-enter the atmosphere here shortly.
It's a very clean, long shot from our long-range camera on the ground in West Texas. Now we're tracking the vehicles now. This camera here is looking at the booster as it's descending. You can see the those wedge fins have deployed off of the top of the ring fin. And so it's able to steer its way back, and shortly here we should see booster relight. All right, here's a nice side-by-side to see the crew capsule on the left side and the booster on the right side of your screen as they're both descending. The booster is winning that race to the ground. It's nearing the ground right now. Those air brakes have deployed, which is really cutting the booster's velocity down. Again, ignore the stats that you see on the screen. Those are not accurate today. All right, there's engine relight. And touchdown. All right. Love to see that clean booster touchdown. And then here's the crew capsule.
Yep, we got eyes on the capsule. As you've noticed, it stopped its spinning maneuver. The payload's inside. We are re-entering the atmosphere. We've experienced up to 5 Gs on descent. We're awaiting parachute deployment. Let's take a look.
There's the drogue deployment.
And there you see the main parachutes being pulled out by those drogues.
Beautiful.
Beautiful. We love to see it. Now, if you've got a keen eye, you might note the parachutes have a slightly new design.
And you can see one of those is lagging on its inflation, but that's all right. We've designed the system to have backups to the backups. This system can safely land with fewer than 3 parachutes. So we're going to continue following this as it approaches the West Texas desert, and it looks to me like the stats that you're seeing on the screen are accurate there for the capsule descent. That's the correct expected descent speed for the capsule after the parachutes have deployed, right about 16 miles an hour. You can see this is a shot from one of our drones. You're seeing the little bit of a helicopter, the blade of the drone there.
Yeah, now as we descend under parachutes, now they are essential for providing a gentle touchdown of our capsule, but like Joel said, we've got many backup systems. One of the nominal systems we use for touchdown is our retro thrust system. That might kick up a little bit of dust here. Let's take a look.
And that third chute looks like it has now inflated, which is great. And touchdown. All right.
Beautiful touchdown of the capsule today on our 29th mission here. Incredible to see. Now our capsule recovery team is currently driving out in a convoy. They're going to meet the capsule. They're going to safe the vehicle and open the hatch and extract some of the payloads today.
Well, that was a great day watching this new vehicle fly to space and back. Not new vehicle, but this new combination of our payloads capsule along with our newest booster. And let's not forget, we want to see, millions of people living and working in space.